So canonical forms are two types. One is the what only standard SOP and standard POS, right? So standard SOP means what? So once again we can recall this. What is standard SOP and standard POS? Those are very important. So in the case of SSOP, that means what? Each product terms contains all the variables of the functions. Okay, na? This is standard SOP, some of the products. In the case of standard POS, each some of the terms contains all the variables of the functions, right? So now see here the difference between the canonical form and the normal SOP. What is the normal SOP and canonical form difference means what? In the normal SOP form, only some variables is appeared in the product term, right? If suppose one product is consist of AB, one product is consist of A, B, C, all the three terms. Another product is also consist of three terms, three variables, right? But one of the product is here and not available the third variable, that is C, right? So in the case of canonical SOP, that is standard SOP, okay na? So it consists of what? All the three variables, okay na? Whatever you are going to take the function, that is a three variable or four variable. So in that those variables are appeared completely in the product term. So that is called what? Standard SOP. Now see next, min term. Min term is nothing but what? Each individual term in the SSOP is called what? Min term. So it is same like, what about the max term? Max term. Each individual term in SPOS is called what? Max term, right? So how we can find out the min terms and how we can find out the max terms? So if you are considering the three variable, okay Nandi, if you are considering the three variable, that is what? ABC. So I'm going to take here n is a what? A three variable, right? So the maximum possible combinations is 2 power 3, 2 power 3, right? That is means 8. So 8 possible combinations, that is 0 to 7 is possible, right? So now see here, this is 0 0 to 1 1 1. So we have to represent the min terms of, when 0 is there, that should be represented as, that variable should be represented as a complement, and 1 is there, that variable is represented as same as it is. Okay Nani? In the case of min terms, okay, in the case of min terms, when a 0 is there, that variable is represented as in the complement to form. Okay na? So whenever it is 1 is there, that should be represented it is as it is, right? Now in the case of max terms it is opposite, right? In the case of max terms, each individual term in the sum of, sorry, such standard product of sums, right? This is sums, totally product, right? So now see here, this is in the case of max terms, 0 is represented as same as it is and 1 is represented as the complement, right? So this is the what? Max term and min term. So as of now it is clear, I think. Hello. Okay, so next we are going to see Kernoff map. Kernoff map or K map. Okay Nandi? Kernoff map. Kernoff map. This is a very important topic, today topic. Kernoff map. So by using this realization techniques, we are going to solve the equations in the digital circuits. Kernoff map, or we can write shortly K map. Now why we are going to use this K map? There are different ways in order to solve the realization, right? There are different different ways available available to solve the boolean boolean expressions or boolean expressions, right? So that is what De Morgan loss is there. So R loss is there, AOI loss and inverter loss is there. Now what is the necessity of this schema? Okay, Nani, what is the necessity of this K map? So K map is also used to K map is also used to realize the Boolean equations realize the Boolean equations in Boolean equations in Boolean expressions or Boolean equations in digital electronics or digital circuits, right? Digital circuits. Now see how this K-map will be built up. Okay, now K-map will be built up. K-map is build up based on the based on the based on the gray code. Okay, Nandi, based on the gray code. What is gray code? So we will see later that is gray code. So there is a code conversions are there, gray code, decimal. There are different codes is there, binary to gray, gray to binary. Okay, na XS3 code is also there. So we will see later this course. So this is K-map is built up on based on the what gray code. Now see what are the types of K-maps. Okay, Nandi, types of K-map. Types of K-map. See here, first one is two variable K-map. Two variable K-map. Second one is three variable K-map. Three variable K-map. Next one is four variable K-map. Four variable K-map. And last is five variable K-map. Five variable K-map. So there are different ways in order to solve. So which variable you have to choose. So those equations we have to solve by using the K-map. Okay, Nandi? So the types of K-maps is what? Two variable K-map is there, three variable K-map is there, four variable K-map is there, and five variable K-map is also there in order to solve the digital circuits. Now see, first we are going to see about the two variable K-map. Two variable K-map. Now see, if two variable means what? How many possible combinations? Two variable means how many possible combinations here? Two variable, what only? Two variable means what? How many possible combinations are available? Four, right? Yeah, 2 power 2 means four possible combinations. Possible combinations. So we know that this is A, B, this is 0, 0, 0, 1, 1, 0, 1, 1. These are the possible combinations when you are taking the two variable, right? Now see how we can represent these in the K-map. Okay, Nandi? In order to find out the output, whatever circuit you have to take, whether it is AND gate, whether it is OR gate, whether it is NOT gate, whether it is XOR gate, if you are going to consider those gates, you have to realize the logic equation for those circuits, right? Now see, what is here? Two variable came up. We have to represent it like this. We have to represent it like this. Two variable came up. So this is consist. Here I'm going to consider A. Okay, na? You are consider whether it is B or A, no problem. So this is A. I'm going to denote like this. Here is B. First box is represented as 0, second box is represented as 1. Here also first box is represented as 0, second box is represented as 1. So 0 represent what? A bar, 1 represent A. Here 0 represented what? B bar. Here 1 represented what? B. Now see, if you are observed the term, this place is what? 0, 0. This place is what only? 0, 0. Right? This place is what only? This is the 0th place. So that means how we can represent this one is the A bar, B bar, right? That means this term is 0. Next, this term ఏమవుతుంది? What will this box indicates? This is here 0, that means A bar. This is what? B. So you have to represent what? A bar B. So that means what? First term. Okay, na? Now what about this term? This box? Here is A. Here is B bar. So you have to write A B bar. Okay, na? That means this term, right? This is you have to represent it too. Now what about this term? A B. A B. Is it clear, Andy? Is it clear? So this is 0 means A bar B bar. 1 means what? A bar B. 2 means what? Is it clear, Andy? Can I explain once again? Please give the response. Okay. So now see here. So I'm going to draw again two variable. Okay, na? This is my two variable K map. So I'm going to consider only four possible combinations, right? That means four possible combinations are available. So that's why I'm going to represent. So two variable nothing but what? Only two variables. That is what? A comma B, right? Only two variables are possible. So I'm represented a like map. So this is I'm considering the A. This is considering the B. So this is B here this way. A is represented this way. Okay, Nandi? B is represented here. That is B having the 0 possibility is there, 1 possibility is there. Similarly, A also 0 possibility is there, 1 possibility is there. Okay, na? Like that, that way these are the combinations available, right? One is the A bar, B bar, that is 0th position. A bar, B, that is the first position. Next, 2. 2 is nothing but what? A, B bar. Okay, na? Like this, you have to follow like this. Okay, na? This is consist of what? 0, 0. 0 is represented what? Here A bar, here A. Here represented what? B, B bar. Here represented what? B. Right? Now see, if you are observing this, is I'm directly going to write A bar B bar is nothing but what? 0th position. So I'm representing the place value. This box place value I'm representing the what? 0 0. Okay, na? Here also I'm representing the box place value is what? 1. So here I'm representing the box place value is 2. Here I'm representing the box place value is 3. So you have to remember place values in the box. It is a very important in K-map. Is it clear, Andy? 0 means what? A bar, B bar. 1 means what? A bar, B. 2 means what? A, B bar. So respective row and column you have to observe only. That's it. Respective row, the box is where it is seated. So respective row and respective column. In the respective row, A is there. Okay, na? Respective column, B bar is there. So A, B bar means what? That is the place value of that box is 2. Is it clear? Is it clear for two variable? Yes? Or is there any doubt? Now see, one circuit you have to realize by using the two variable, right? This now see here. First I'm going to realize AND gate truth table. AND gate truth table. What is AND gate truth table? In order to find out the AND gate equation I want, right? AND gate equation I want, right? So we know that AND gate truth table, AND gate logic is what? Dot, right? So this is my A, B, output Y. 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 means what? 0. 0, 1 means what? 0. 1, 0 means what? 0. 1, 1 means what? 1. Right? 1, 1 means what? 1. Now see, we have to use the, in order to find out the logic expression for this AND gate, we have to realize using K map. We have to realize the K map. So there is a two variable, right? There is a only four boxes available. This is A, this is B. This is 0, this is 1. Here also 0 and 1. Now see, where it is once is there, you have to represent it, right? First you have to note down the place values of boxes. This is the 0th place. This is the first place. This is the second place. This is the third place. Okay. Now you have to remember here also 0, 1, 2, 3. Now where you have to represent the 1, that should be wherever 1 is there, because we are going to consider only min terms. Okay, Nandi? We are going to consider only min terms. So wherever 1 is there, okay, Nandi? Wherever 1 is there, that will be represented in that place. So in which place 1 is available here? In which place 1 is available here? Third place, right? Third place. So third place 1 is you have to, as it is you have to write. Okay, na? So those are zeros, right? Those are, this is 0, this is 0, this is 0. So wherever 1 is available, okay, na, that will be our logic equation. Okay, Nandi? Wherever 1 is available, that will be our logic equation. So there is a pairing is there. Okay, Nandi? Pairing is also there. Pairing. Pairing means what? Two ones you have to form the one group. Two ones, four ones you have to form the one group. Four ones, eight ones you have to form the group, or 16 ones you have to form the one group. So groups is also there. So later we will see what is this pairing. Okay, na? Now see, this equation is what, and if one is there, only one is there. So this is the what, one ki emundi manam rasa box lo, what will write here? One represent what, andi? AB. So from this y is equal to, I can write what? AB. This is AND gate, right? So by using this came up, we can solve the, we can realize the logic circuits expressions. Is it clear now? Is it clear or any doubt? Came up is a very important topic. Shubham? Shubham is there? 38? 38? Hello? No one is there?